In this video, I'm going to continue talking about the in-class review packet starting on the third page, number 11. So remember, we don't have to do the table. That's just there for if you like to use it, but you can just use the pattern instead. First question it said, or first thing I noticed really is that it's in standard form, okay? And the C value is missing, which means it's just a 0. And A says, what is the axis of symmetry? Well, lucky for us, we're in standard form. And if we're in standard form, we can easily find the axis of symmetry by using the formula negative B over 2A. So A is a 1, B is negative 8, and C is 0. So negative B just means the opposite of B. So the opposite of B is positive 8 over 2 times A, which is 1. So I have 8 over 2, which is 4. So my axis of symmetry is 4. So if we want to go ahead and plot a, graph our line there, we can see that the axis of symmetry will be here at x equals 4. Okay? Then it says, what are the zeros? Well, in order to get the zeros, I need to have my graph here. So after I find the axis of symmetry, my next step is to find my vertex, because my vertex is very important in getting the graph going. So I know that the vertex, even though it doesn't ask me for it, I'm going to have to find that. The vertex's x value is a 4, because that's the axis of symmetry. And to find the y value, I take 4 and I plug that into the function. So I have y equals 4 squared minus 8 times 4. Okay, and if you do that, you get 16 minus 32, which is negative 16. So I see my vertex is at 4, negative 16, which is way down here. Okay, and it is on that green line, which we already knew was going to happen. Now, we can already assume that since the vertex is way down here at the bottom, that this graph is going to be face up. But we also know that it's face up because the A value is a positive 1. So that means it's going to look like this. Since A is a 1, that means we also are going to be able to just use our pattern. So from the vertex, I'm going to shift over 1, up 1, 1, up 1 on both sides. Then I'm going to go back to the vertex, and I'm going to go over 2, up 4. And then I'm going to go back to the vertex. I'm going to go over 3, up 9. And then lastly, I'm going to go back to the vertex. I'm going to go over 4, up 16, which is going to get me here at my x-intercept. Okay, general rule is you want to go over and up as many times as you can to get to those x-intercepts so you can see exactly where they are. Now that I have it, my points plotted, I can go ahead and connect it and include arrowheads. And I can see that my zeros or my x-intercepts are at 0, 0, right here, and at 8, 0. Which also makes sense because the center point between 0 and 8 is 4. So 0 and 8, the center would be at 4. So that does make sense there. Okay, let's try another one. This one is also in standard form. First thing I'm noticing, though, is that A value is a negative 1, which just means that I'm going to be face down. So I'm going to keep that information in mind. It also asks me which way does it open, and we already know it opens down because the A value is negative. To find the axis of symmetry, I'm going to use the formula negative B over 2A. A, B, and C are given there in the equation. So negative B means the opposite of B. The opposite of B is positive 4 over 2 times A, which is negative 1. So I have 4 over negative 2, which equals negative 2. So the axis of symmetry is x equals negative 2. You need to have the x equals there. That's also the x value of the vertex. To find the y value of the vertex, I take the negative 2 and I plug that in. So I have that negative 1 in the very front, parenthesis, negative 2 squared, minus 4 times negative 2, minus 5. If that negative sign in front of the x squared throws you off, write it as a negative 1. That might help you out. And I can just type that whole thing in my calculator. So negative 1, parenthesis, negative 2 squared, minus 4 times negative 2 minus 5. And I get negative 1. So my vertex is at negative 2, negative 1, which is right here. I also can tell what the y-intercept is just from looking at the equation there, because your y-intercept is just your c value, in this case negative 5. So that tells me that my parabola is going to go through the y-axis at negative 5, right here. Since the a value is negative 1, I can go ahead and do my pattern. From the vertex, I go over 1, down 1, over 1, down 1. Back to the vertex, over 2, down 4. Oh, look, that's our y-intercept, right? Back at the vertex, over 2, down 4. And that's enough points. 5 points is enough. And it says, does the graph have a maximum or a minimum? What is it? The graph has a maximum in this case. At the vertex. Now, it doesn't ask us here what the x-intercepts are, but you'll notice that this parabola does not touch the x-axis. So if it said, what are the x-intercepts? You would say there are none. It does not touch the x-axis. Okay, last problem on that page is another graphing problem. This one is slightly different, you'll notice, because we do not have an a value of 1. We have an a value of 4, but we know how to accommodate for that. So we'll go ahead and get started here. We see our c value is 0 because it's missing. You could either graph this from standard form as it is, or you could factor it, totally up to you. I'm going to do it from standard form because that's what we've practiced, I feel like, more often than not. So that's what I'm going to do. So negative b over 2a. Negative b means the opposite of b, so that would be positive 8 over 2 times a, which is 4. So you have 8 over 8, which is 1. So that means my axis of symmetry is going to be here at 1. Sorry, my line's a little messed up there, but at 1. So that means my vertex is going to be 1 comma something. We don't know yet. So I take 1 and I plug that in. And I get 1 squared is 1, so I get 4 minus 8, which is negative 4. So I get 1, negative 4. So over 1, down at negative 4, that is the vertex. Now, it hasn't even asked us for that. We just had to find that. If we're going to graph from standard form, we have to find that first, axis of symmetry and vertex. I'm here. Now, I noticed immediately that the a value is 4, okay, not 1. Which is fine. We can still use our pattern, but we're just going to have to manipulate it to account for the fact that the a is not a 1. So I take my normal pattern that I would use, over 1, up 1, over 2, up 4, and I'm going to multiply these values by whatever a is. And in this case, a is 4. So I'm going to multiply by 4, and I get 1 times 4, which is 4, and 4 times 4, which is 16. So now I'm going to be using these values. So instead of going over 1, up 1, I'm going to go over 1, up 4. So from the vertex, I go over 1, up 4. Over 1, up 4. And then instead of going over 2, up 4, I'm going to go over 2, up 16. So from the vertex, I'm going to go over 2, up 16, which I think is going to be a little bit off the grid. That's up 4, up 14, 15, 16. Over 2, up 4, 14, 15, 16. So just a little bit off the grid there. Okay, and we can see that when we connect it there, that's a pretty skinny parabola. And like I've said in class, guys, the bigger your a value, the skinnier the parabola is going to be, because that's increasing at like 4 times the rate of our normal parabola when the a value is 1. So it's going up 4 times as fast, so it's going to be a lot skinnier. Now that we have it graphed, we can see the roots are at 0, 0, and 2, 0. If you had taken this equation and factored it instead, and graphed it from factored form, you would still get this same exact graph, and you would see that the roots were 2 and 0. We also see that the y-intercept is at 0, 0. We can see that from the graph. It crosses the y-axis here at 0, 0. And we can see that because that is the c value in the function. All right, so if the a value is not 1, you graph it the same way we've always graphed it. The only difference is you have to manipulate the pattern in order to do so.